Okay, I just wanted to split that into two videos so you don't have to sit through like a half an hour or whatever, and you can come back and watch different sections. So after going through the five requirements and how they are disrupted for genetic equilibrium, I thought that was a good place to stop. This video is going to be describing the four types of natural selection. So first up is stabilizing. Individuals with an average form of a trait have the highest fitness in stabilizing selection. You can think of the bell curve, where everybody there's just kind of meh in the middle. And it's not really that everybody's meh, but it's just the average, excuse me, the average form of the trait is the most common. So for this example in the picture, you see it's about body size. Of course, any trait can be looked at as far as stabilizing selection is concerned, but body size is just an example. So for this particular lizard or gecko or whatever it is, if they are too large, they're more easily seen by predators. It's harder for them to hide. If they're too small, then they're too slow to actually run away from predators. So the average form of body size is the most common and produces the highest fitness. Directional selection is where individuals display a more extreme form of a trait. And a good example of that is the anteater. The longer the tongue, the better. So the bell curve that you will see for directional selection, the red line is for the average bell curve, and the blue line represents directional selection. So if you think of a trait where either a more or a less extreme version of the average form is favored for fitness for a species, that is an example of directional selection. The next type of selection is called disruptive. This is where individuals that have either extreme have the highest fitness. An example, oh my gosh, were we going back to, I don't remember what chapter it was on, but basically it looked at these shellfish, and you have white shelled shellfish, and you have dark shelled shellfish. Shellfish, it sounds like selfish. Anyway, so if you look at shellfish, you've got two versions, a light color and a dark color. The light color on the rocks covered with white barnacles cannot be seen, but dark shells that are on dark colored rocks also can't be seen, but the medium colored shells can be seen either on light or dark rocks. So you will see for this particular species, you'll see either very light or very dark colors. So again, the red line represents the average bell curve, and then you've got the disruptive selection curve where you see that both, or I should say not both, but either extreme is favored, either super light or super dark. This would be an area where you have, perhaps you've got, let's say on your shoreline. So let's say this is the beach. Oh, that shouldn't be Curtis. Here's the beach. Here's the water. And let's say on the beach you have, it's hard to see, but let's say you've got like very light colored rocks, and down here you've got very dark colored rocks. And so when the tide goes out, you have the dark rocks which are exposed, and so these guys will still be camouflaged. These guys are seen all the time, so you have to have the light color on that live up here all the time, and these guys are going to live on the bottom. But if you're medium shelled, you're going to be seen whether you live outside of the tidal zone or under the water. So basically you're going to get preyed on, and the numbers will decrease over generations. So you'll see either light or dark colors. And the last type of selection is called sexual selection. This is going to have two effects. One, that it is a type of natural selection, but also two, it violates rule number 4 of genetic equilibrium, which is random mating. The best example of sexual selection is in birds, because for birds, the very brightly colored birds are always the males. So for the peacock, the very beautiful, big, huge tail with the feathers and all that, that is a male peacock. The females are going to look the same, but they're not going to have these giant tails, and they are brown, very boring brown. So the downside of being this gorgeous is that you are very easily seen by predators. So the question is why? Why would natural selection allow this kind of adaptation where you have this bird that basically has a huge target on its back? This like, look at me, I'm right here. I've got all kinds of really shiny blues and greens and purples. There has to be a reason why this particular trait was allowed to evolve over such a long period of time. And that is because this is the sole criteria that female peacocks use to select mates. The females are going to pick a mate based on physical characteristics. So males that don't have a big, beautiful, full tail will not be able. They won't be picked to mate with, and so those genes that have coded for this like pathetic small tail or whatever it is, they're not going to continue for the next generation, and only the genes that produce these big, beautiful, colorful tails are going to continue over the next generation.
In Papua New Guinea, the bowerbird has lovingly rebuilt and redecorated his bower. Another visitor.
This is the male,
This time, it's a female.
and you see how different her colors are.
This is just where he wants her. Time to begin the show. First, he expands his pupils alternately. It's an oddly mesmerizing display. A spot of limbering up, accompanied by a weird and wheezy call from deep in his throat. Now it's time for his grand performance. He waves his wing like a matador's cape. She appears to be transfixed. This is certainly eye-catching, but it seems he needs to do more. Generously, she drops him a hint. It's the bird equivalent of a bouquet of flowers. It's all going so well, it's time to get physical. With a few headbutts to her chest. One final flourish to cap weeks of effort. Something's wrong. His rival is back, and at the worst possible moment. What should he do? For the female, the moment has gone. Sometimes, whatever you do, things just don't work out.
So that's an example of a group of birds called birds of paradise. I believe that they live on the island of Papua New Guinea, and the males, because it's such a small island, and these birds, sorry, I hear my dog wandering around the background. These species all live in a very small island, and so they become like super specialized, and the males develop these really elaborate courting rituals or mating rituals. And you saw in that previous video, he built her the little entranceway that you saw there so that she knows where to sit and watch him like dance. And then she showed him like the berry, like, I want you to dance with this thing. And then his male rival showed up and then like ruined the whole thing, and he didn't get what he wanted. So birds of paradise, very interesting.
They go from expected to extraordinary in the blink of an eye.
You're awestricken. They transform themselves to something that you've never seen before.
They swagger and serenade. They dance and display. They're unlike any creatures on Earth, and one of the most astounding phenomena ever witnessed. The birds of paradise. Found here in the nearly impenetrable mountains and valleys of the island of New Guinea, in the greatest remaining tract of rainforest in the entire Asia-Pacific region. They exist nowhere else on Earth.
The vast majority of the land around here has no road access. You're just looking up into a wall of steep slope, and you can tell that this is just ridge after ridge and valley after valley.
Evolutionary biologist Ed Scholes and wildlife photographer Tim Lehman have spent the better part of a decade trekking into this isolated wilderness in pursuit of all 39 species of these miraculous birds.
The only way to see a kingbird of paradise is to climb up into the trees where they live, so I'm heading up to my platform.
They've been photographing, analyzing, and recording their every move, every behavior, in an attempt to comprehend their secrets. And in doing so, revealing extreme examples of the miracle of evolution.
Birds of paradise represent one of these singular events of evolution that stand out, that are extraordinary. They're something that's without precedent, something that evolved that's so unique and so exceptional that you're driven to say, why, or how did that happen? How did that come to be?
That's the female.
The birds of paradise are remarkable not only for their exceptional beauty and almost otherworldly appearance, but as veritable living textbooks on adaptation and sexual selection.
The females are looking at this whole package and can discern something about him by minor variation. The more complex it is, the harder it is to make it look right. You know, if one little feature is out of whack, you're going to be able to tell.
What about New Guinea has led to these birds evolving here and nowhere else? What function do their outrageous plumes and ornaments play? And what exactly are they doing?
For me, it still always goes back to the original driving question, you know, and that's, how did it happen? How did the birds of paradise come to be?
Witness diverse strategies of evolution at work and experience one of nature's most extraordinary hidden wonders up close. A world where beauty and behavior are intertwined. A spectacle not possible any other place on Earth.
Okay, so you can see the difference between the male and the female birds in that video. And like I said, the birds of paradise are a very unique group of birds that only exist on the island of New Guinea, and their evolution and like how they look so spectacular and so beautiful and like such weird behaviors to attract mates is unique to anywhere in the world.